Welcome to my video class. It is part 6 of the chapter Quadratic Equation, and that chapter is mainly for preparation of JEE Main and Advanced and for different state level joint entrance examination. Today is 7th part, and first problem is problem number 32 of the chapter, and the first problem is the equation whose roots are each increased by 1. Of the roots of the equation, x squared minus 3x plus 4 is equal to 0 is option x squared minus 5x plus 8 is equal to 0, x squared minus 5x plus minus 8 is equal to 0, plus 6 is equal to 0, x squared minus 5x minus 6 is equal to 0. The problem is one quadratic equation is given and we have to find another quadratic equation whose roots are each increased by 1 of the roots of that. Suppose roots of that equation is alpha and beta. So to find the equation whose roots are alpha plus 1, beta plus 1. Two very simple way we can solve that. Very simple way, and because it is symmetric, let us take symmetric alpha plus 1, then beta plus 1. But if one is alpha plus 1, other is beta minus 2, not possible. So suppose this is x is equal to alpha plus 1. So alpha is equal to x minus 1. But alpha is the root of that, must satisfy it. So x minus 1 whole square, x square, that is alpha square, minus 3 into alpha, that is x minus 1, plus 4 is equal to 0. That is x square minus 2x plus 1 minus 3x plus 3 plus 4 is equal to 0. So that it is actually equal to x square minus 5x, 2x and 3x, 5x plus 8 is equal to 0. So this one is answer. Mind that this method can be applied if only these roots are symmetric. Otherwise, we can solve it in this way. Alpha beta roots of that. Therefore, alpha plus beta is equal to 3 and alpha beta is equal to 4. So our required equation is x square minus sum of the roots. Now root is alpha plus 1, beta plus 1. Alpha plus 1 plus beta plus 1 into x plus product of the roots. Now they together alpha plus beta is our 4. So x squared minus they together is 4. This is 5. This is 6. Oh, sorry. Alpha plus beta is 3. Sorry, very sorry. Alpha plus beta is 3. So 3 plus 4, 5. 5x plus product of the roots is alpha beta plus alpha plus beta plus 1 is equal to 0. That is x square minus 5x plus alpha beta is 4. So 4 plus alpha beta is 3 plus 1 is equal to 0. So once again we get the same result, x square minus 5x plus 8. First option is correct. Now next problem, problem number 33. Problem number 33 is the condition that both roots of the equation ax square plus bx plus c is equal to 0 are negative is options ab positive, c negative, a positive, b and c negative, a and c negative, a, b, c are of same sign. The once again the problem is this is a quadratic equation standard form x square plus bx plus c. If its both roots are negative, then what is the option? First option is A, B positive, C negative, and so on. The sum of the roots, suppose alpha and beta are roots, then sum of the roots is minus b by a, and product of the roots alpha beta is c by a. Now, given that both roots are negative, if both roots are negative, this is negative, so sum is negative, so that must be negative. That is, b by a should be positive, and product of the roots negative into negative positive. So c by a must be positive. Now suppose a is negative. If a is negative, b should be, and because b by a is positive, so b should be negative, and c by a is positive, a is negative, so c must be negative. So we get that if a is negative, b is negative, then c also is negative. That is, they are of same sign. Maybe that a is positive, then it must satisfy this and that, because some equation roots are of negative, both are negative sign, so this by that is positive, this by that is positive. Assume that a is positive, then b is positive. From here a is positive, so c is positive. So if this is the case, then only both roots are negative. So from these two, we can conclude that if A, B, C are of same sign, either all three are negative or all three are positive, then roots are both roots are negative. So option C is correct. Option B, fourth option. Next. Next problem is problem number 34 of that chapter. In 34, in ax square plus bx plus c is equal to 0 if b square is greater than 4ac. Number 1, AB is negative and AC is positive, then which of the following is true? Options are one positive root and one negative root. Both negative, both positive, not possible to predict, to determine. The option is one positive, one negative, both positive, not possible to determine. Okay, let us see what is the problem here. This is a quadratic equation. Given that in that quadratic equation, b square is greater than 4ac and ab negative, a into c is positive. Then nature of the roots means one positive, one negative, or and so on. Options are that. So in the first option, b square is greater than 4ac. It means the roots of the equation are real. Now, it is true, this is also true. So, suppose A is negative, then what would happen? A into B is negative. A is negative, so B is positive. And A into C is positive, A is negative, so C is negative. This is one case. And if A is positive, A may be positive or negative. So I consider here A is negative. Now consider A is positive. In that case, B is negative and C is A positive. A into C is positive, so C also positive. So another case is this. Now to determine whether roots are one positive, one negative, and so on. Now clearly, if alpha and beta are roots, alpha plus beta is equal to minus b by a, and alpha beta is c by a. If this is the case, a negative, b positive, a negative, that is sum of the roots is positive. If and a negative, c negative, in that case, product of the root is positive. Product of the root is positive. So for that case, if a negative, then this is true, this is true. In that case, we say that we understand that sum of the root is positive, product of the roots is positive. So both roots are positive. So both roots are positive if this is true. it may so happen that A may be negative. Uh, oh, sorry, I'm sorry. Alpha plus beta is minus B by A is positive here, considering which one? A negative and B positive. B positive, A negative. In that case, sum is positive. And product is C negative, A negative. Product is positive. So, if this is the case, then both roots are positive. Now, if this is the case, this one, A is negative, B negative, A negative and B negative, so this ratio is positive, so ultimately negative. Oh, sorry, no. A is positive and B is negative. Negative by positive is negative. Sum is positive. And A positive, then C again positive, so product is positive. So again, if A is positive, then also both roots are positive. তাহলে in that case, we must have মানে conclusion is this both roots, if this is true, this is true, this is true, both roots are positive. So option C is correct. Next. Next problem is problem number 35. If alpha beta are roots of x 2x square minus x minus 1 is equal to 0, then the equation whose roots are 2 alpha minus 1, 2 beta minus 1 is what? Options: x square plus 2x minus 1 is equal to 0, x square plus x minus 1 is equal to 0, x square plus x minus 2 is equal to 0, x square plus 3x minus 2 is equal to 0. The problem is alpha beta roots of that equation, that quadratic equation. Then to form one another equation, quadratic equation whose roots are this and that. Here also the roots are symmetric. The new roots are symmetric. If it is 2 alpha minus 1, other is 2 beta minus 1, symmetric. So let us take x is equal to 2 alpha minus 1. From here we get alpha is equal to x plus 1 divided by 2. And now we conclude that if alpha, not if, alpha is a root of that, it is given. So alpha means that must satisfy it. So that we have 2 into x alpha square, x plus 1 by 2 whole square minus alpha is once again minus 1 is equal to 0. That is, this is by 4, so x plus 1 whole square by 2 minus x plus 1 by 2 minus 1 is equal to 0. Multiplying by 2, we have x plus 1 whole square minus x plus 1 minus 2 is equal to 0. That is x square plus x 2x plus 1 minus x minus 1 minus 3 rather. That is, equation become x square plus x minus 2 is equal to 0. X square plus x minus 2 is equal to 0. Option is, so this one, option C is correct. Next, problem number 36. Problem 36. The range of A so that both roots are x square minus 2ax plus 2a minus 1 is equal to 0. Just 1 minute. X square minus 2ax plus 2a minus 1 is equal to 0 are greater than half. Options are a is greater than 0. Next, 1 less than a less than 4. A is greater than 3 by 4. A is less than 3 by 4. Now, the meaning of that problem is that one quadratic equation is given. Here, A is one unknown quantity. We have to find the range of values of A, that unknown quantity A, so that both roots of that are greater than half. So, we can find the roots of the equation by using Sridhar-Acharya method, and by that we get roots are alpha comma beta is equal to minus b, that is 2a plus minus root over b square 4a square minus b square minus 4ac by 2a. So these two, that 2 will be cancelled, and its roots are a plus minus root over of a square minus 2a plus 1, and 2 cancelled. It is equal to a plus minus a minus 1 whole square. Not whole square, and that root cancelled. So actually roots are, uh, 1 is alpha is equal to a plus a minus 1, that is 2a minus 1, and beta is equal to a minus a cancel plus 1. Now the condition is that, oh, I think I had, oh, greater than half. Achha, okay, both roots are greater than half. Achha, clearly one root is using negative sign, we get one root is 1, which is clearly greater than half, and other root is 2a minus 1 should be greater than half, that is 2a should be greater than 3 by 2, that is a should be greater than 3 by 4. So required range of a is a greater than 3 by 2, that is option C is correct. So now next problem. This is problem number 37 of that chapter. if alpha beta are roots of x square minus px plus q is equal to 0, then the value of alpha to the power 5 plus beta to the power 5 minus p into alpha to the power 4 plus beta to the power 4 plus q into alpha cube plus beta cube is how much? One is pq, other is 0, third one is p square plus q square plus 2, and fourth option is pq plus 1 by 2. Given a quadratic equation, x square minus px plus q is equal to 0, alpha beta roots. Then to find value of this in terms of answers are in terms of coefficients pq, 0, etc. This can be written as alpha to the power 5 plus beta to the power 5. And this one, oh, one thing, alpha beta roots of that. Therefore, alpha plus beta is equal to p, alpha into beta is equal to q. Now put these values of q in terms of alpha and beta. So this is equal to alpha beta into alpha cube plus beta cube minus p into alpha to the power 4 plus beta to the power 4 is equal to alpha to the power 5 plus beta to the power 5 plus it is alpha to the power 4 beta plus alpha beta to the power 4 minus, keep it intact, this one. So from this and that, take alpha to the power 4 common, alpha plus beta. From this and that, take beta to the power 4 common. So it is alpha plus beta minus p into alpha to the power 4 plus beta to the power 4. Now taking alpha plus beta common, it is alpha plus beta into alpha to the power 4 plus beta to the power 4. But alpha plus beta is your p. So this is p into alpha to the power 4 plus beta to the power 4 minus same thing. So cancelling, this is equal to 0. So here 0 is our answer, that is option B is correct here. Okay, let us stop today. So I request you to share the video. If you like it, then subscribe it also. So thank you.